Hello and welcome everyone to my channel Code with Ease. As part of this linked list series, this is the second video. In the previous video, we discussed about linked list insertion and insertion at the beginning, insertion at the end. Insertion at the end also covered traversal through the linked list. In this session, we are going to see how do we do the deletion, which means how do we delete a node in a single linked list. The problem statement says we are given a singly linked list and one integer x. We have to delete the xth node from the linked list. So as we see in the example 134, x is 3. Now here the x doesn't denote the data value of the linked list. Here x denotes the index of the linked list. Now the question arises, just like we have zero based index in array, we linked list, we do not have any index as such. How do we talk of the index then? So what happens here in the explanation, it says after deleting the node at the third position. So in this, we are going to use one based index. It's nothing but we can just use one counter variable and we keep on incrementing as we traverse through each of the nodes. Since it is one base indexing, which means the first node is going to have index 1 instead of index 0. So it will be index 1, then index 2, then index 3 and so on. So here since x is 3 and the node at the third index is this, that is the one with the data 4. So that is removed and what we get in the output is 1 and 3. In the second example, however, x is 2 and the second node is 5. 5 is removed and we get 1, 2 and 9. What we have to do is we are given two things. We are given an address of the head and we are given the integer x. We have to return the head of the modified linked list. That's it. Okay. So now let's see how do we solve this question. Okay. Let's see. Okay. Let's define one current node which is going to point to head. Okay, x is going to be the index. We'll say int index equal to 1 because it's going to be one based index. So let's see what is going to be the first condition for us. um, if we have to delete anything at a particular index, we have to do a traversal. Okay, now what happens is, like if I talk of the second example, if x is 2 and we have to remove 5, if I remove 5, ideally 1, the node before 5 should point to 2. That is what is happening. 1 is pointing to 2, which means if I just do a plain traversal through the linked list, it will not be enough. Plain traversal, I mean, if we do a plain traversal only using the current pointer, we also need a pointer that will point to the previous node to keep track of it, so that when we reach to a node whose index matches x, like in this case x equal to 2, once we reach 5, automatically the previous pointer should point to the next of 5, that is 1 should point to 2. Once 1 points to 2, the link is broken between 1 and 5. Once the link is broken, means 5 is removed. We don't have to explicitly remove anything, we just have to break the link between the node to be deleted and the previous node, and the previous node will point to the next of the node to be deleted. That's it. That's the entire logic that we have to achieve. Next is we have to talk of some edge cases. So if something is in the middle of the linked list, x equal to 2, 3, 4, it's good. What if x is 1? X is 1 means, okay, why I want to talk of this as an edge case, if we always have a previous pointer, it's easy to just say previous dot next equal to whatever the current dot next is. If the first node, means the head node only, has to be deleted, which means if x was 1 only, if that's the case, what will be our new head? The new head will be obviously the next node to the head node. So then in that case, our head pointer should point to this. So that is going to be our edge case. So that will be little different from the normal logic that we will have. So let's see what we do for that. We'll say if the index, that is whatever the index we are at, that is equal to 1, if index equal to x, or x equal to index, whatever. We are just talking of this because if head itself is the node to be deleted. Okay. So if that's the case, our new head should be what? Our new head should be head dot next. And then we are saying, they are saying that we have to return the head of the linked list. So once this is done, we just have to return the head, new head. That's it. This is the edge case. Otherwise, if it is not, then we can have a normal while loop and we can do the traversal. But remember, apart from current, we also need to have a previous pointer. So we'll say node priv equal to null. Initially, when we are starting with this traversal, when we are at the first node, what we have in the previous? Nothing. So null. Then we'll say while current, the current node, while current is not equal to null. Okay. And we will say that while the index that we are at is not equal to x. Because if they are equal, we'll see what we have to do. If they are not equal, assuming they are not equal, we keep on moving till we reach to that point where index and x is equal. So if that is the case, we will first do what? Priv is already null, so we have to assign something to priv. What will priv hold? Priv is going to be my current node. In the first occurrence, priv is null, so priv will be equal to 1. Current is also 1, but now current will move. So my current will be current dot next. So now current is at 5, priv is at 1. So that is how it should be, right? Previous should be the previous node and this is the next node. So once this is done, then what else we have to do? Here index is at 1. We have to keep on incrementing the index as and when we traverse through the list. So our index will be incremented. So index plus plus. So this will keep on going till any of these conditions become true, become false. So either when you reach till the end of the loop or till the point when your index is equal to x, this loop is going to run. Now what happens is, if my index is equaling the x, that is one condition when the while loop will break. So we'll do this check. If index equal to x, then what we will do? We have reached that node. Let's say this is the node. We have reached 2 and 2 is the culprit node that needs to be deleted. So what we have to do? Our priv will be pointing here. So we'll say priv dot next equal to current dot next. So we are breaking the link between previous and current. So now previous is pointing to the new node, that is the next node of current. That's it. And once we are done with that, we will return the head. This is all like assuming that whatever the x is given, that is existing. Okay. So let's try to compile this. Okay, we'll submit this. Okay. So the problem is solved successfully. So now we can see that with this logic we can delete a node in a single linked list. So now we are done with linked list insertion and we are done with linked list deletion. So in the upcoming videos we are going to explore some more linked list questions related to whatever is being asked in the interviews. So stay tuned and do let me know in the comments if you have any doubts or questions or any suggestions. And don't forget to subscribe to my channel Code with Ease. Thank you so much for watching the video.